Hello and welcome to Deep Dive Types of Precipitation. Precipitation is the cornerstone to all things meteorology, and it is very important to understand what types of precipitation form at what temperatures and how temperatures at different altitudes affect precipitation to move forward into meteorology. So let's jump right on into it. So, the most commonly observed precipitation type is rain. Now, rain forms because of the water cycle. We're just going to use that as the basis of everything here because even though we're focusing on precipitation today, the water cycle is the origin of all that precipitation and it matters. So, evaporation, condensation, precipitation, most people learn it in science class. So evaporation, the sun heats water sources, water vapor evaporates, so it goes up. When it gets to a certain point in altitude, it condenses, forms clouds, and then when those water droplets get too big, they fall as precipitation. That's the basics. But raindrops have to measure at least 0.02 inches in, I believe, diameter for it to not be considered drizzle. So drizzle and rain are totally different, and it actually comes down to the diameter of the drops. So smaller drops are considered rain if they are widely separated. So kind of the difference between fog as well. So fog, you could have drizzle and fog. Now, drizzle is uniform precipitation composed of small water droplets very close together. So that's what drizzle is compared to rain. Freezing rain is the next coolest, so I'm moving from warmest to coolest types of precipitation. So this occurs if the warm layer in the atmosphere is deep with only a shallow layer of below freezing air at the surface, starts as snow or sleet, becomes rain moving through the deep warm layer, and then freezes on the below freezing ground. So the ground is frozen, it's called becoming supercooled in the air and freezing on contact. So, but above that, it has to come from snow to rain to become freezing rain, and that is where that deep warm layer comes into play. Now, let's move on. Sleet, we have a shallow warm layer that just slightly warms up the snowflakes. They become like ice crystals inside of an outer area of rain, and then it gets refrozen, and then it's just a kind of small hail type thing. So transparent or translucent pellets of ice, irregular grains of ice consisting of frozen raindrops, can also occur from melted and refrozen snowflakes. That's actually more common because everything starts as snow. That's because of the average temperature of the atmosphere. In the troposphere, the air gets super cool at the top, so when those precipitation starts to fall, it always starts as snowflakes. Now, Graupel. This is a very unused term generally in normal life, but it's precipitation of white, opaque grains of ice that are round, diameters are less than 1/4 of an inch. So basically, this is either like semi-snow or just smaller hail. So in the description here, we can see snowflakes pass through super cold air and water and freeze into Graupel, tiny balls of ice smaller than typical hail. Now, that kind of has a similar depth of that warm layer to sleet, but that deep cold layer is there as well, but it just doesn't have the time to completely melt, so it slightly melts, reforms into that hail, quote unquote. Snow. Most people, if you live in the very north or the very south of either the northern hemisphere or the southern hemisphere, have experienced snow before. So snow is basically rain when air temperatures remain below freezing throughout the atmosphere. So the environmental temperature stays below freezing, but you can experience snow at temperatures above 0 degrees Celsius or 32 degrees Fahrenheit if that layer on the ground is so shallow that the snowflakes don't have any time to melt. So it's precipitation of ice crystals, have 6 branches extending from the core. And that's where the saying comes, no two snowflakes are alike because of the processes in forming them. Hail. Hail's really cool, and we'll talk about this more in thunderstorms and lightning, because hail is usually, it's indicative of severe thunderstorms, but it's small balls of ice, and they're associated with thunderstorms, and they're a quarter of an inch in diameter or greater. But to have a severe thunderstorm warning issued, the hail would have to be 1 inch in diameter or more. If it's 1/4 inch to 1 inch, you would usually get a special weather statement from your local NWS office. Now, hail starts by raindrops being sucked into the updraft of a thunderstorm. So then it all freezes, hail growing and circulating convection currents until the hail is too large for the cloud to hold, falls to earth, causing strong cold downdraft. And if you ever get hail, and quickly grab it, because usually it'll warm up and melt very quickly depending on what size it is. If you cut it open, you will see layers, kind of like you see the rings of a tree, and that tells you how old the tree is. Well, kind of the same thing happens with hail. The amount of layers that there are is a direct correlation to the amount of times that it gets sucked back up into that updraft, which is super cool. That is all I have for precipitation. Thank you guys for watching, and I'll see you guys next time.